The title of this lecture is a custom VTK. We will do the Python because it's a lot easier. Mini application with Qt. And it starts on page, right here, on page 99 of the notes. And it goes to page 114. So custom VTK, why would you, custom mini app, why would you do that? I said it already. You want a very simple interface to do just a couple of things, just a couple of buttons, a couple of sliders, a save screenshot option, an open file option, and you're done. So here's an example of it. But I had this other example right here, which is an application I have developed to test the multiple rendering options of VTK. So the first one is OpenGL, which we have here on the screen. So what is this we're looking at? We're looking at a bone sample. So it's a bone, a human bone, yes, which has been scanned by a TAC machine, a CAT scans in English. From this we have built the geometry. The geometry is right here. So you can already kind of guess the very empty, porous nature of the bone. And here we have a screw. The screw is what they're called orthopedic implants in proper English. When you break a bone, if you break it really badly, you get screws and all those things on your bones. And the insurance company pays for it. I've experienced that on myself. So there, however, it looks pretty poor here because we can't really recognize what's going on. It would be nice to do shadows. So if I do shadows, I would go like this. And now it should be a little bit better. But I have other options as well. First, I should open the denoiser. I also have the option to do path tracing, and the path tracing will do there we go, there's a little bit too much light in here. I need to reduce my number of samples. And there's the denoiser. And finally, there's the NVIDIA, the NVIDIA ray tracer, which gives me real-time navigation. There. And here you see a very crisp image. This will be in the lecture of tomorrow in ray tracing. And you see something interesting in that picture using that image synthesis process uses machine learning to improve the picture as well. Anyway, a simple interface. So how do we do it? If I compare this with ParaView, ParaView is over here, and I will turn off the parallelism right away so I don't forget. This is the graphical user interface of ParaView. If I get here, so multiple panels, multiple options. A big part of the source code of ParaView is just user interface, and this is built with Qt. Qt is this well-known library to build graphical user interfaces. All right. So the idea would be to have the main window to do 3D graphics, and then a very small graphical user interface. So if I go back to my examples from earlier, I will show you over here. You will recognize the elements of my interface, so the pull-down menus, the 2 buttons, and the 3 sliders, and here an empty window. And this is how I will build my graphical user interface using the Qt Designer. And the Qt Designer is something that allows you to assemble together the different widgets you need, and then you import the VTK pipeline code which you have from a standalone application. Now, if I go here under I can preview this. There we go. Forget about this. Can I minimize? Yeah. No, I can't. Otherwise, everything disappears. Okay, anyway. Here's the preview of my user interface. Here I have my sliders, I have my buttons, I have my pull-down menus, but nothing is active. There's no visualization yet. So the exercise is about creating this user interface and then importing the VTK into it. This is actually the exercise I have prepared. Here's what are the requirements. VTK compiled with this particular option. VTK wrap Python, Boolean on. And then I use on my laptop PyQt5, which is installed in that particular way. You can also use other Python Qt bindings. Okay, PyQt5 is not the only one. And then you need Qt Designer. And by the way, there are some very nice notes about very simple programming examples with PyQt at this particular address. So the first thing to do, launch the designer, choose the main window theme, and that's our window. We get an empty window. No problem with that. We add a couple of frames to the container from the container menu. One of them we call the VTK panel. And this is where the 3D graphics will reside. We select both of them and we put them into a layout so that they are bound together. Those two windows will stick together in the horizontal manner using a so-called splitter. We set a minimum geometry to be 190 pixels, which means my menu never completely disappears. This is basically how it looks in the Qt Designer. Those two Q frames, the splitter. By default, I have the menu bar and the status bar. And by the way, at this time, you are probably thinking, oh my gosh, I got to be an expert in Qt as well. No, you don't. I am not an expert in Qt, absolutely not. I've learned this. This is the minimum, this is the bare minimum you need to learn just to do those mini applications. And it's probably, I don't know, 2 or 3% of the whole Qt thing. But that's all you need to do. Then finally, we add our widgets. So we build the graphical user interface by adding a layout to the main window and then adding the widgets. So the combo box, the radio button, and the horizontal slider. And I will demonstrate that after the presentation. I rename one slider to be the resolution. I select the combo box and I add 3 items. One of them is point, wireframe, surface. This is just like the ParaView interface, by the way. And this is where we have to be smart here already. We add them in that particular order because the default value for the combo box starts at 0, then go to 1, then to 2. And there are exactly the same values that VTK uses to set the representation type to points, that's 0, wireframe is 1, surface is 2. Then we quit and we save this application as the UI file. So that UI file I have over here. It's not quite the example I had. Something got changed in here. Minimum size, 100. So perhaps I will just start from the beginning again, just to demonstrate the process. So designer, I get a main window and I say create. Then from the container menu, I get frames, a container, I get 1 frame and a second frame. Okay, one of them will be for the graphical user interface, one of them will be for the window. This one we rename VTK _ panel, just like this. We select both frames and we put them into a horizontal layout. There we go. And then we select our frame here. Well, we can actually stretch them like this. Whoops, There we go. Now I said that I wanted a radio button, so I add a radio button, just like that. I wanted I wanted a combo box. If I don't find it, I just look for it like that, combo box, and I put a combo box on top. Then I wanted an horizontal slider, which I get over here, there. I've built up my user interface. If I select my combo box, I edit items. I add 3 items. One of them is points. The other one is a wireframe. And the last one is surface. Okay. My slider is renamed to be resolution, etc. And I'm almost there. Now let's follow up further. Once I have that UI file containing all the widgets and the Q frames, which is where I am now, points, radio button, and slider, I need to define my VTK pipeline. So if I go back to my first image, this is the pipeline. This is my mini application. I want a single sphere. I want to change the resolution of the sphere. And I want to change the mode from wireframe to surface or to points. This will be my visualization pipeline. Okay, so in Python again, but you can do the same thing with C++. This would be our pipeline. I think now we are familiar with it. Get a sphere object, which is a sphere source. Set the resolution, the phi and the theta resolution. Get a mapper. Show this mapper with an actor, get a renderer, and then I'm missing the render view, but it's there, and then an interactor to start the interaction. Let me demonstrate that particular example. So there, this would be, there's nothing much to see there. In wireframe mode, it's a little bit easier. There's a sphere. See, the problem is that it's very simple to define a mini visualization pipeline in VTK, but then as soon as you have it working on the screen, you say, gosh, it would be so nice if I had just a couple of buttons, a slider, and then I would be done. So that's exactly the case. So now we have this VTK pipeline, this VTK Python pipeline ready to go. This is what we want to import into our Qt application, in our Qt framework. So what is missing? We're missing a slider to change the resolution, and then the pull-down menu to select the representation mode, which means we're going to have to connect the methods of the VTK elements to the actions created by the graphical user interface. Let me show you that particular script here. Okay, here I have really all the details. So the renderer, the render window, and the render window interactor, and then I can put as many spheres as I want. I selected to do just one here, a VTK sphere source, where I set the file resolution and the theta resolution like this, then the polydata mapper, etc. I set the size of the window, I start, and then I'm done. That's my application. Which I have summarized here. Okay, so I now have to connect the graphical user interface to the VTK object. The combo box has a signal called activated. The resolution slider has a signal called value changed. And then the button, the radio button, has a signal called clicked. And those are fixed name, clicked, value changed, activated. They are fixed. They are part of the API of the Qt widgets. So basically, connecting them to our pipeline is done through some callbacks methods. So for example, for the resolution slider here, I say connect that particular signal value change to the method called set resolution. And set resolution is nothing else than the sphere object and the method called set file resolution with the value, new value coming from the widget. And then we trigger the rendering of the graphics as again by calling render window render. Now, how did I find out about all this? The object sphere source in my VTK pipeline over here, that's the definition of it. If we click on those objects, we have here the class definition in VTK. And we have here exactly the API for that object. And those methods, we've seen them before. There is set theta resolution, get theta, set phi, set center, etc., etc. So that's one object. There we go. The second one is the slider. So again, I reference the QSlider object on the web documentation for the Qt API. And I have here exactly those events for the Q. Let's go back to the top. There. Abstract slider. Those are all the different functions that slider responds to. And it has this over here, this value change slider. So as soon as I move the slider, the value gets updated. And this is the signal I need to connect. Okay? So there's no magic to it. I just look at the documentation of the two objects. The Qt object I want to connect to the VTK object I want to connect. There we go. I do the same thing for the combo box. So the combo box, if you recall, allows me to change between points, wireframe, and surface mode. So it's options 0, 1, and 2. And those options actually are set up at the VTK property level. So if I go to the documentation for my property object, I have it right here. Set representation it takes an integer as an argument. The first value is 0, which corresponds to set representations to point, and so on. And then I have wireframe, and I have surface. The combo box documentation tells me this. The signals are called activated, and it takes both a string, a Q string, or an integer. So it's very convenient, this overload of the method, in that I can either pass the word wireframe, or I can pass the number 1 to the VTK object. Same thing for the button. I think you've probably understood the logic now. For each graphical user interface widget, there's a name for a particular signal. When you click on a button, when you move a slider, when you open a file, etc., those generate events. We connect those events to methods of the Python object, which are defined. You can give those any name you want, and in that name you do some action on the VTK object. Now, there has to be some magic taking place, and that magic is the UIC compiler. The designer application creates a file called something .ui. So in our example here, mini application qtvtk.ui. So you tell Python to open that file and to use the UIC compiler to generate a Python program. So we have converted the Qt UI file to a Python code. And then we put both Python codes together, and we have it. So we compile the code like this, and then we create, and those lines are exactly, you cut and paste those 5 lines for each mini app that you wish to have. You derive your main application from the Q application object. You create your main window, you show your window, initialize, and then exec. Just to show you something, there's my mini app file. Frankly speaking, I don't know what to expect. Oh yeah, it's XML code. XML code with your different widgets definition. So there's my central widget, the splitter. There's one Q frame. Here's the combo box. With points, wireframe, surface. Here's the radio button, etc. But this is just XML code. If we look now at the same file name with the Python extension, this is written here very clearly. This was created by PyQt UI code generator. This is not something you should edit. In fact, I wouldn't want to. This is pretty messy. But it's automatically generated for you. So you use the designer in a very user-friendly fashion to create your application. The UIC compiler makes this particular text for you. And then, in your mini app, I go straight to the bottom here to show you. I open my UI code, I compile it as a Python object, and now this mini app QTVTK Python code is open as PyUI files, and we will find this name again at the bottom of our application. Let me get to it, let me show you. Import mini app QTVTK. So the file that was automatically generated by the compiler gets imported here as a Python repository. This is most likely pretty abstract until you do one of them, and once you do one, then they all seem pretty, then it's all automatic. It probably took me several days, I don't know, no, maybe half a day to do the first one, and all the other ones, it took me 20 minutes to do them. I have built several of them like this because they're quite convenient. This is also something you use as a template if you follow the PyQt5 option as I have done. So you import your VTK. From VTK, QTVTK render window interactor, you import that particular class. From the PyQt5, you import the UIC compiler, the Qt widgets, the Qt object, and then you define your own class for the viewer. I don't expect to go through each line of those pages. You have it in the note. I can give you the source code to replicate that example on your laptop, and then from there, I can help you, not today, not tomorrow, because we don't have time, but in a separate communication via mail, via whatever, I can help you make your own example based on that particular application. What do I want to, basically here highlight the connections of the slots for the 3 different widgets. So, oh, actually, no, I didn't do it. So I'll show it to you in the source code right here. Here they are. It's a little bit verbatim. There's a lot of text too, but there's my VTK panel, remember, that I had defined. And here are the 3 widgets I had defined. The combo box, the resolution, the radio button. So for each of those events, activated, value change, clicked, I connect them to a function I have defined elsewhere in the code. Switch mode, set resolution, and button event. Let's look at, for example, the switch mode. There it is. See, it's really pretty simple. It's a couple of lines of code here. I get the actor, which was linked to the representation of the sphere, and I say set representation with my value, and then I render. For the button click, I didn't do anything. I just print button was clicked just to demonstrate that it works. And then there was one more, which is the set resolution, for the sphere. I set both the file resolution and the data resolution to the value received from the slider. So when I have this in action, I run it like this. There's my sphere. There's my resolution button. And I can change my resolution. I can click the button as often as I want. And I can change my representation modes. Okay? There. We will not attempt to do this in a 30-minute exercise because it would be too complicated. But that example is completely available. There are basically two things: the UI file, where you can reload the graphical user interface description into the designer. It would be a good exercise, simple to do, to modify one of those widgets or to add one more widget, connect it through to the VTK pipeline. And then the second thing that is available is the Python code itself describing the pipeline. The same thing can be done with C++. Now with C++, it's a little bit more involved because you have to use CMake, so you have to write a CMake file. But I can show you example here. And I will, whoever is interested, I will give you this file, this star file of exercises. They are all written in C++. They all demonstrate different levels of connecting a Qt interface with a VTK C++ pipeline description, each of them with a different degree of difficulty. I have converted those examples, basically the CMake files. Those were causing problems because this is an old set of exercise, and I forgot who I got it from, unfortunately. So I cannot give proper credits, but I believe it must be somebody from Kitware, the company making the VTK and ParaView application. So it's a set of examples, I believe, from somebody at Kitware, which I have now updated to run with the most recent version of CMake and of VTK. And you can exercise each of those. As you can see, of interest is the basic VTK pipeline, VTK with interaction, Qt show VTK, and then VTK Qt. Those last two examples are interesting in that what I have described earlier is you take events from the graphical user interface and you use them to modify the VTK pipeline. In that last example, you do the opposite. You go from VTK to Qt in that something that is happening in the VTK pipeline, in the 3D window, actually modifies the widgets of Qt. So there you have the complete set of possible interactions from Qt to VTK and from VTK to Qt. So all of those are exercises, are demonstrators are available. Just send me an email and I will send them to you. So in summary, we started from this very simple design of an application. And you see, you don't even have to worry about the proper positioning of the widgets because Qt is very smart about splitting, connecting, packing the widgets all together nicely. So you have really very minimal effort necessary to do this. You build your graphical user interface panel, and then you leave an empty frame here where all the graphics takes place. So is any of you interested in doing this particular type of mini application? Yes? It takes a while. I think the important part is, first of all, define a visualization pipeline, which you are interested in. And then see, is ParaView too big for me? Do I need parallelism? Do I need, all those questions have to be answered. And then if at the end you say, hey, I'd like to have something that is so simple, instead of telling people, you download ParaView, that's 300 megabytes, first of all, people tell you, oh, no, I don't have time and space to do that. You say, no, look, I'm going to send you 2 pages of Python code, which you run, and it's all integrated. You install your Qt packages on your laptop, and then you're ready to go. So that's one very good way to exchange also some know-how. There we go. So this is kind of the summary here for this exercise, creating mini applications with Qt. There is another place, another opportunity where we want to shrink down ParaView. It's when we do in situ visualization. At lunchtime, a few persons have talked about Catalyst. So Catalyst is the in situ library for ParaView. The problem is that you have to load Catalyst with your application in memory. And oftentimes, especially I hear that with large-scale computation on the supercomputer nodes, memory is already something quite limited. There's little room to link with other libraries, etc. People always try to streamline as much as possible what gets linked into the executable. Unfortunately, ParaView is pretty big. I compiled it yesterday for Dome. This is our test and development machine. I counted 608 sub-libraries which are linked in to the executable. That's pretty big, eh? And if you look, well, not so much at the size of the executable ParaView, but all the shared library, there are 608 shared libraries. So pretty big. There's a way to streamline. So Catalyst is fully integrated into ParaView. But there's a way to streamline that so that you don't bring in all this big weight of libraries into your own application when you run in situ. This is something I could explain to you in a different setting. There we go. So those mini apps, the best I've created is something that perhaps has 5 or 6 different buttons and sliders, and it has the most important 2 functionality that you know for every application is open file and save screenshot. I mean, this is because we're doing visualization here, so we have to save the image. And those are really trivial. There's 5 lines of code here and here to open. Getting a file dialog is a fully implemented widget in Qt. So there's really, the Qt part is 5% of your effort. Your main effort remains creating the visualization pipeline itself. Good. I'm done with this particular presentation. Now we have a half hour left to answer more questions. Any questions for the whole day with what we've done? Try more exercise. Try reading some of your own data with ParaView. Try applying some of the things we've learned to your own visualization activities, and then show me where you have questions related to your own thing. I will not answer each person individually, I don't have time, but then we continue this discussion in the weeks to come, okay? So this is the time to show me, hey, this is what I would like to do with visualization, but I have no idea how to. Can ParaView help me? This is the time to do that, okay? All right, end of this presentation. Now it's free time for questions and resolving more issues.